Hi everyone. Hi. So welcome back to my channel. Okay, blah. Okay, so the reason why I actually do the part one, the video into two parts actually is because that I forgot to bring my battery charger. So tiba-tiba dia tak ada battery. So I have to stop the video kalau tak I lose everything that I have explained to you guys just now. So that is why I separate the video for the explanation for 7.1 part 1 dengan the tutorial question for 7.1 part 1. Okay, so ada dua video for this part 1 punya tutorial. Okay. So I hope that you don't mind that lah. Okay. So this is the tutorial discussion. So in the previous video, so you have to watch the previous video, chapter 7.1 part 1.1. Okay, you have to watch that video before you watch this video, part 1.2. Okay. So you have to watch the video dulu. That video explanation dulu baru you tengok this video. Okay. So let's discuss the question. So I will not discuss all the question here. Okay, in the tutorial question I only will discuss a few of the question because I hope that you can do it by yourself, because like some of the question like you need to do it by yourself lah kan, takkanlah semua benda Miss nak ajar, betul? So let's look at the question 5 first. Okay, question 1, 2, 3, 4. I think you can do it by yourself. Be very senang. You can refer the question. You can refer the explanation notes from my video. You can refer to the slide notes. You can refer to reference book and everything. Okay, so it's very simple. So I'm going to teach you for question 5 until question 9 in this video. Okay, it's just a basic question, and the other questions are from question 10, 11, 12, 13, 14, you can answer by yourself. Okay? Alright. So let's look at question 5. So it says that calculate the pH value and determine whether the following solutions are acidic, basic, or neutral. So let's look at question 1 first. Question 1 plus question A first. So here it gives you the what we call it, the concentration of now is 0.62. Okay? Alright. So, here, the 0.62 is actually for OH minus lah. Sebab apa? Kalau you buat kan? Kalau you buat, okay, now ni, kalau you buat macam ni, dia actually dissociated completely, betul tak? Kan betul? Sebab dia akan dapat macam ni. Okay, so actually, since this adalah 0.62 mole, since the 1 mole produce 1 mole of sodium hydroxide produce 1 mole of OH minus, so secara tak langsung ni pun adalah 0.62 molar. Betul? Okay. So here we know that tadi kita tahu Kw is actually equals to the concentration of H plus, okay, times the concentration of OH minus. Okay, we want to find the pH value, right? So we need to find the H plus ion apa? Betul? So we know that Kw is equals to 1.0 times 10 to the power of negative 14. Am I right? So we can find the H plus here. So H plus here is actually equals to Kw divided by concentration of OH minus. So we get here the concentration of H plus here is equals to 1.0 times 10 to the power of negative 14 divided by 0.62. Okay, and we will get the concentration of H plus ion is equals to 1.613 times 10 to the power of negative 14 molar. So we got the concentration of H plus. So now, can we use it to find the pH? Yes, because we have concentration of H plus, right? So we know that here, we know that pH is equals to negative log H plus. So, kita substitutekan lah value ni betul. So, negative log times 1.613 times 10 to the power of negative 14. We will get the pH is 13.79. So, we know that since pH is larger than 7, which is 13.79, hence the solution is basic. Okay? So that's how you answer this kind of question. Okay, next we look at question B. Oh, tak cukup ruang. Susah sangat tulisan Miss Kalau masa kena padam ni Okay, so boleh So if you want to salin this answer, you want to understand more, you have to pause this video lah kan, so that you can understand, because I have to delete this. Okay, so bye bye answer, bye bye jawapan. Okay. Wait. Okay. Okay. So now we are going to look at question B. Okay, question B, it asks you 1.4 times 10 to the power of negative 3 molar HCl. So we know juga HCl ni adalah strong acid, betul? Tapi kita dah tahu, tapi dia nak suruh kita tunjukkan lah, betul tak? Kita dah tahu dah dia acid, dia base. Tapi dia nak kita tunjukkan juga, betul tak? So, kita kena tunjukkan lah kan? So, dia bagi kita, so kita tahu strong acid dia completely ionized. So, dia punya concentration of H plus sama dengan concentration of initial dia, betul tak? So we know that now we have the concentration of H plus is actually equals to 1.4 times 10 to the power of negative 3 molar. So we know that pH is equals to negative log H plus. So substitutekan dia punya value. So 1.4 times 10 negative 3, we got pH equals to 2.85. So, kita cakap kat sini. Okay. Jawapan kat sini cakap, since pH is less than 7, 2.85. Tadi Miss cakap untuk soalan A tu larger ke? I think larger kot. Kita kena rewind balik video. Okay. Tadi tu, yang tadi A tu larger, pH larger than 7. So, sebab tu dia basic. So, since yang untuk B ni, since pH is less than 7, so, the solution is acidic. Okay. Tadi basic, ini acidic. Okay. Now, kita tengok soalan C pula. Soalan C, water. Distilled water. Okay, distilled water kita tahu dia neutral, tapi dia nak suruh kita tunjuk dia neutral. So, kita tunjukkanlah macam ni. Tunjukkan dia, Kw is actually equals to H plus times OH minus equals to 1.4 times 10 negative 14. Okay. So, dia nak cek kita pH kan? So, H plus is equals to KW divided by OH minus. So we know that KW is 1.4 times 10 negative 14 divided by OH, which is 1.0 times 10 to the power of negative 7. So we get H plus is equals to 1.0 times 10 to the power of negative 7 molar. So kita boleh cari dia punya pH equals to negative log H plus. So we get negative log 1.0 times 10 negative 7. We will get pH equals to 7. So answer dia kat sini. Since pH is equals to 7, the solution is neutral. So that is how you answer this question for number 5, A, B, and C. Okay. So now we look at question number 6. Okay, for question number 6, we have this. So we have a sample of orange juice has a pH of 3.8. Calculate the concentration of H3O plus and OH minus. So maksudnya dia nak cari concentration untuk H3O plus dan OH minus. So first, kita cari dulu concentration of H3O plus. Dia bagi kita pH kan? Okay, so we know that here, pH is equals to negative log H3O plus. Betul? So dia bagi kita ni, so kita guna H3O plus lah, betul? So, kita boleh gunakan, kita tahu pH punya value 3.8 sama dengan negative log H3O plus. So, kita nak cari ni, kita kena pindahkan negative log ni pergi sini. So, kita akan dapat negative 3.8 equals to log H3O plus. Ini saya bagi tunjukkan untuk awak nak kira kalkulator macam mana. Okay? Kalau tak tulis step ni pun tak apa. Okay? Awak terus ini pergi dekat jawapan pun tak apa. Okay, so kita nak tahu concentration of H3O plus is actually shift log ni kan. Jadi base dia 10 betul tak? So 10 to the power of negative 3.8. So we will get the concentration of H3O plus is actually 1.6 times 10 to the power of negative 4 molar. Okay. Alright. Okay, sekarang ni kita nak kira concentration untuk OH minus ada dua cara. Satu, kita cari POH, lepas tu kita cari OH minus. Satu, kita guna KW equals to concentration of H plus times concentration of OH minus. Mana-mana jawapan pun boleh. Okay, kita buat jawapan, kita guna yang POH punya, okay. So, kita guna yang POH punya method. So, we know that pH plus POH is equals to 14. So, kita boleh cari POH is equals to 14 minus 3.8. We will get berapa? 14 minus 3.8. 14 minus 3.8 is equals to 10.2. So, can we find the concentration of OH minus now? Yes. So, we can get POH is actually equals to negative log OH minus. So, we have POH now right here. So, we got 10.2 equals to, so 10.2 is equals to negative log H plus. So, we can say that kita akan pindahkan negatif tu ke situ. Akan dapat log, OH minus. Kita akan pindahkan negatif 10.2 is equals to log OH minus. So we can find the concentration of OH minus is actually equals to base 10 log to the power of negative 10.2. So we will get concentration of OH minus is 6.0 times 10 to the power of negative 11 molar. Okay, so you dah dapat concentration of H3O plus, you have dah dapat concentration of OH minus. Okay, so this is you get lah. Boleh guna cara mana-mana pun asalkan betul lah jawapannya. Okay, konsep method dia banyak method. Okay, banyak method actually. Alright, so we move on to question number 7. So for question number 7, it asks you, what is the molarity of OH minus in aqueous solution of NaOH if its pH is 13.5? Very, very good. So nak cari OH minus kat sini, pH dia 13.5. So first step apa? Cari pOH. How? Okay, you know that pH plus pOH is equals to 14. So we have pH here. So we can find pOH is equals to 14 minus 13.5. Okay. So we will have here pOH is equals to 0.5. Okay, so we know that pH is equals to negative log concentration of H plus. Betul? So we will get here, kat sini pOH 0.5 sama dengan negative log. Oops. Asyik H plus je miss kau ni. OH minus. Suka sangat dengan H plus. Okay, OH minus. Okay, pOH ni. Okay, so kita akan dapat 0.5 equals to negative log OH minus. So we will get negative 0.5 equals to log OH minus. So we will get OH minus is actually equals to base 10 power of negative 0.5. We will get the concentration of it as 0.32 molar. So this is the concentration or the molarity of OH minus. Okay, molarity to concentration lah. Okay, so we get this answer. Okay, alright. Next, we move on to question number 8. So it asks here, how many grams? Okay, tiba-tiba je how many grams kan? Soalan dia boleh putar-putar macam-macam. So how many grams of sodium hydroxide is needed to prepare 500 centimeter cube of NaOH solution with pH of 10? So bagi kita molar mass 40. Okay, so first step kita kena cari dia punya concentration of OH minus. Okay, how? Kita guna pOH. Macam mana nak cari pOH? Guna pH plus pOH equals to 14. Okay, so we know that here pH plus pOH equals to 14. So kita boleh cari pOH is equals to 14 minus 10. So we will get the pOH is 4. Okay? Alright, so kita boleh cari concentration of OH kat sini kan? So we know that pOH is equals to negative log OH minus. So we will get the pOH is so OH minus here, is equals to 10 to the power of negative 4. So we will get the concentration of OH is 1.0 times 10 to the power of negative 4 molar. Okay. So when we have the concentration of OH minus, kita boleh carilah concentration of, secara tak langsung boleh cari concentration of NaOH. Sebab apa? 1 mole of NaOH will form 1 mole of OH minus ion. Betul tak? So we know that concentration of OH minus is equals to mole of NaOH divide by volume solution. Okay, dekat sini kita tahu. So, kita boleh cari mole dekat sini, betul tak? So, mole NaOH needed is equals to concentration of OH dia berapa? 1.0 times 10 negative 4 molar times dengan volume tadi 500 cm3 tukar jadi decimeter, which is 0.5. 0.5 liter. Betul? So, we will get the mole needed is 5.0 times 10 to the power of negative 5 mole. Kita nak cari dalam bentuk grams, betul tak? So, we know that mass of NaOH needed is then equals to mass times dengan molar mass times dengan mass. We know that number of mole is equals to mass over molar mass. So, nak cari mass, kita kena kali mole dengan molar mass. So, 5.0 times 10 to the power of negative 5 mole times dengan molar mass 40 gram per mole. We will get the mass needed is 0.002 gram. So, this is how you answer this question. Okay? Alright. So, we're going to look at the last question, question 9. So, question 9 is quite complicated. So, yeah. So, first, kita punya soalan dia kata write an expression for the dissociation constant Ka of propanoic acid. So, kita buat dulu propanoic acid punya dissociation constant. So, Ka is equals to, when we do the chemical equation, we get this chemical equation here. So, this one, the Ka is actually equals to concentration of CH3 CH2COO minus times concentration of H plus divide by concentration of CH3 CH2COOH. So, this is the expression for Ka. So, the next question, it asks you to calculate the pH of 0.35 molar solution of propanoic acid at 25 degrees Celsius, given that the Ka is 1.35 times 10 to the power of negative 5. Okay, first step. Maksudnya kita cari the concentration of H plus lah, betul tak? Sebab kita nak dapatkan pH. Am I right? So we know that the initial concentration of propanoic acid is 0.35 molar. Okay, kita kena buat ice table ni, okay? So, initial untuk produk tak adalah, betul tak? Okay, so change dia sebab kat sini dia punya stoichiometric coefficient 1. So, minus X ni plus X untuk produk. So, at equilibrium, this is very important. The blank here will be 0.35. 0.35 minus X. This one will be X. This one will be X. So, we know that X is actually the concentration of H plus. But how are we going to find the X? Okay, dia bagi kita KA, betul tak? So, kita boleh buat expression KA. So, we know that KA is equals to CH2COO minus divide by CH3CH2COOH. So, which is actually equals to, so KA dekat sini dia equals to berapa tadi? 1.35, betul? So, KA is actually 1.35. So, 1.35 times 10 to the power of negative 5. So, kat sini, at equilibrium, x squared divided by 0.35 minus x. So, disebabkan actually KA is very small for weak acid. So, we can use the approximation method. Okay, tapi ada syaratnya kan? Okay, syaratnya ialah dia punya percentage of dissociation must be less than 5%. Baru kita boleh guna assumption. So, we need to find the 5% tu ada ke tak. Okay, macam mana? So, kita buat kat sini. Assume, okay, x minus, assume that 0.35 minus x is approximately 0.35. So, we can say that x squared divide by 0.35. So, apa ini? Bila awak tolak dengan x, seolah-olah sama dengan 0.35 kan? So, 0.35 juga. So, 0.35 equals to 1.35 times 10 to the power of negative 5. So, we will get x is actually equals to 2.17 times 10 to the power of negative 3. So, we got x 2.17 times 10 to the power of negative 3. So, kita kena assume dia punya percentage of dissociation less than 5% or tak kan? So, we cakap. So, percentage of dissociation is equals to x over c times 100%. Third, so equals to 2.17 times 10 negative 3 divide by 0.35, kan? C initial dia times 100%. So, we will get here 0.62%, which is less than 5%. So, we can use approximation method. Okay. So, kita boleh teruskan guna approximation method. So, we know that now. So, kita boleh padam yang ini. Okay. So, we know that now. X is actually equals to 2.17 times 10 negative 3. Okay, which is actually equals to concentration of H plus. So, can we find pH now? Yes, we can find pH. So, pH is actually equals to negative log H plus. So, we will get negative log 2.17 times 10 negative 3. So, we will get pH is equals to 2.66. Okay? So, what happened lah kan? What happened kalau we cannot use the approximation method? Katakanlah the percentage of dissociation larger than 5%. So, we need to use the quadratic formula. Okay? Kita kena guna yang tadi tu. Yang kita kena ambil kira 0.35 minus x. So, kita ambil kira yang tadi tu. Ka is equals to x squared divided by 0.35 minus x. So, kita kena dapat dua value of x. Okay? So, kita kena pilih which x yang kita boleh pakai untuk dapatkan concentration of H plus so that kita boleh cari pH. Okay? Tapi sebabkan kita boleh guna approximation method, so kita boleh ambil terus value of x yang kita cari tadi awal-awal. Okay, so itu untuk question B. So for question C, so what the question C ask? Calculate the percentage of dissociation. Actually dah cari, tapi sebabkan ini soalan C, kita cari lagi. Okay, cari lagi, tak apa. Okay, so kita tahu percentage of dissociation is equals to x over c times 100%. So we will get x is actually equals to 2.17 times 10 negative 3. C is equals to 0.35 times 100%. We will get percentage of dissociation is equal 0.62%. So this is the answer for question C. Okay, so we have finished the tutorial punya discussion. So kita dah discuss question 5, 6, 7, 8 and 9. So what are you going to do for your homework, your task? You need to complete, okay, tutorial questions 10, 11, 12, 13, 14, 15 for me. Okay? Alright. So this question is, so soalan 10 sampai 15 ni is related to the explanation and tutorial from part 1 punya 7.1. Okay, 7.1 part 1. So maksudnya kita dah cover lah. Okay, sorry, 15 is not. Until 14 only. Okay, 10, 11, 12, 13, 14. Okay, so yeah. So this is your task. Okay, so we have finished this part of tutorial discussion. So that is all for today. Okay, don't forget to watch the previous part 1, 7.1, part 1.1. Okay, before you go into this. Alright, that is all for today. Bye-bye. Assalamualaikum.